Ma'am will be talking about bridging linguistic diversity with generative AI, machine translation, and beyond for Indian languages. Parameshwari Krishnamurthy is an assistant professor at the Language Technologies Research Center, International Institute of Information Technology, Hyderabad. Her doctoral research at the University of Hyderabad delved into computational linguistics with a focus on Telugu Tamil machine translation, emphasizing divergence. Prior to her current position, she held the role of assistant professor at the University of Hyderabad. Krishnamurthy's expertise lies in computational linguistics and machine translation, spanning areas such as morphological analysis and generation, parsing, linguistic divergence, contrastive grammar, and corpus linguistics. She actively participates in numerous natural language processing projects, particularly those concerning Indian languages and Dravidian languages, aiming to advance core technology tools and NLP applications. It's a pleasure to have you, ma'am. Over to you, please.
Thank you. Thank you as well. It's a really too many things you talked about it. Yeah. So I would like to share my screen. Uh,
Please. By the way, would you like to take the
okay.
questions at the end or in between, ma'am?
Yeah, I am okay to be stopped in the middle and
Sure, sure.
kind of pondering towards three different presentation because I want to capture some of the things. So in case if you find any difficulty in looking at my slides, please also let me know.
Sure. Thank you.
Yes. So I think yeah, Professor Arnab Bhattacharya, as I think definitely might have given you a proper background before my study, and thanks for sir giving that one. And as I see the kind of timetable, you I think have started looking at the LLM, understanding the LLM, and also different applications are all being covered. So let me also just kind of quick view on this LLM and especially LLM for the Indian context. And within Indian context, the most important thing is language barrier because all of us speak different languages, and if a machine helps us in uniting all of us through a technology like machine translation, that would be the wonderful thing for us, right? So we will be talking about what are these LLMs, or in a machine, like if we want to build an applications like machine translation, what kind of approaches are there. And let's say LLM is like a kind of tool which does all multitasking thing. What is the position of LLM right now for Indian languages and how to go beyond it? That would be a kind of talk I would be going towards. So when we take LLMs, of course, we all know that it is a type of AI, especially generative AI. So the idea here is it is trying to mimic the human in terms of like generating the human language. And again, massive drove of data is being used to train these LLMs. As we know, it's a data hungry thing. As long as the data is enough, of course the quality of the LLM also comes out well. And when it comes to Indian languages, again the questions like, do we have that kind of massive data? Are we resource rich in terms of the data that are required for LLMs? Are again a difficult thing to say right now, but of course there are some study which we also conducted, we would like to discuss here. And the aim is, of course, we want to produce the human like responses, especially when we are dealing with natural language, right? Natural language, we all know that it's a human property, right? Like it's part and parcel of our human, and if it evolves along with the human, anything that happens in human life also reflects in language. And historically, language also evolves in terms of new words, new sentences, new vocabularies, and new ideas that are being expressed. And let's say now the influence of using social media, we all know that the language that are being used in social media is totally different, and also there is a generation gap in the way language is being used. There are Gen Z languages, right? The way language is being evolved along with the human being is uncontrollable. And let's say if we want to mimic that one, let's say at a particular period of time, with a huge amount of data, that's what we are trying to do, right? So that's the aim of LLM. At the same time, it should evolve along with the human being. right? So now the capability of LLM, what is all of us know, it is just a next word prediction engine. Of course, the parameters helps us in defining how much next word or previous understanding of the language is required, and it has an ability to perform a wide range of NLP tasks. The tasks like summarization, sentiment analysis, machine translation, question answering, or a chat, or if you have any doubt, it's there to help us in lot of information. Okay, so as we know that language modeling earlier is like more of uh, at least 10 years back, it's a statistical way of looking at and modeling them. And 20 years back, it's all about expert system, building the model from the scratch, use lot of linguistic derived knowledges and build it. But these days, large language models, are more of decoding engine, helps us generating it through the knowledge it has. So there are a lot of models that are available. Of course, this I would say is still an old picture, but if you want to have a new LLMs that are right now available, there are varieties of LLM, versions of LLM, domain specific LLM, and multimodal LLM. All of them are becoming very, very popular. But of course, the most important thing that we need to understand, most of them, it started with something like Ngram, like word to vec, and some of the other linguistically motivated approaches. Slowly it has taken up I could say taken up a big transformation in terms of using transformers in or like covering up the language, understanding the language in terms of the mathematical, combinations of languages. Okay, when it comes to the NLP, as I told you, the whole idea of NLP is try to mimic the human brain. But how human brain works on language understanding as well as generation, processing, and let's say generation, is not that easier way to understand. It's a very complex system, too many things are being involved. And language, in terms of language, it's not only the grammar of a language plays an important role. More than beyond the grammar, there are, the things like world knowledge, pragmatic knowledge, cultural knowledge, non-linguistic parameters that we normally use in languages. Everything plays an important role. So somehow brain has an ability to understand it, signal it, and generate it wherever required. So now GPT, all these things are, we know that it is a generative pre-trained transformers. I'm not getting more deeper into this kind of thing. Anything that you see in ChatGPT kind of LLMs have three important things. One is pre-training the model, and also instruct and tuning, and alignment to the task. So the task can be anything. It can be an answering question, completing the task, or engaging in conversation. So of course, the answering questions, like you can ask for any information about any events, or you can ask it to complete the task, is like summarize the data, translate the language kind of thing. And you can also engage in conversation like chatbot, assistant, or customer support kind of task. So the main features of these LLMs are enormous size, either in terms of data as well as model, and also computationally. Also, it's rich. It requires a rich computation power to train it, and it can be it can pre-trained and fine-tuned for a specific task. And transform learning is a part of parcel of LLM. And of course, generation, understanding, multimodal capability, contextual learning, and application. So in a way, it's like one item which has everything, right? So I think most of us like let's say biryani, than having a rice, sambar, rasam separately. We need one dish which gives us a taste of everything, right? So let's say biryani, it is just on one dish, but we are okay to eat that one dish. But because we want to get the taste, aroma, and our hungry feeling ability, right? So similarly, LLM is trying to do that one. It's like a khichdi of everything. We want to make sure that it does everything whatever that we ask. Okay. And when it comes to the task, this is again a little older slide, but when you commit the task, the most important task that we could say, using LLM, people want to use it as a chatbot, question answering, summarization, and some kind of code completion. We all use it for, like, make sure the code is being completed, and some kind of logical inference from the data and translation. That's what I'm more interested to talk about it here, because India being a multilingual country, the major problem that we all face every day with language, especially in a cross linguistic conversation, is like language. The one language speaker will not understand the other language speaker, right? Okay, let me get into my second slide to talk a little bit about uh, the task that I'm going to talk now. I hope my screen is visible. Is this visible? Professor Oswald, is my screen visible to you? Somebody can maybe tell me. Oh, yes. So I think I has changed my slide into something else, machine translation. Hope that slide is visible to you. The slide name is machine translation. Okay, thank you. I'm trying to make sure this is. Just a minute. I'll make it as a PDF to make sure that. Okay. Just give me a second. I'm trying to make it a bigger. Thank you. Thank you. I think. Okay, I'll make it little bigger. Yeah. I hope now the slides are
Yeah,
visible
perfect. Perfect.
with the. Yes. So let's now understand what the task of machine translation. The task of machine translation is actually automating the process of translation from one language to another.
Sorry, could you please maximize your slides, please?
Oh, it's not maximized. Just give me a second. I thought that.
Maybe you can change into present mode.
Okay, okay. I'll share my screen again. Is this okay? Okay, I hope this
It's
is.
perfect, ma'am.
Yes, thank
Yeah,
you.
it's perfect.
So,
Thank you.
yes, yeah. So, when it comes to the machine translation, yes, it is not a replacement to any human translation, because, again, the slides are too small. I don't know. I'm trying to adjust the thing here. Dr. Aswald, if anything that I had, like, let me know. But I'm going, like, ahead of my talk. But in case if you need anything, you can tell me. Okay. So when it comes to the machine translation, the whole aim of building this kind of tool is not to replace any human translation, but enhance the human translation, because we need to, translate too many things. Normally, human translations are costlier effect, right? Then, so again, it is an interdisciplinary field. The understanding of language is important. There comes in into the picture of study of linguistics, and the the language experts. The fluency of the two languages are very important. So native speakers play a very important role in either even in development and evaluation of these empty models. And of course, to process it, to model it, we also need to have a proper understanding on how it can be done, architecture. All these things are very important, and it has both generation and understanding, whereas LLMs are mostly natural language generation engine. But machine translation in a nature by any human, we need an understanding of the source language, as well as you need an understanding of how that information has been passed on to the target language, right? And so the understanding behind like the meaning behind languages is very important. And also we need to generate the same quality of the output that normally a human being require. Okay, so for example, let me take a sentence now. The task is, if you give a source language, the task is it should give you the equivalent in target language. Let's say they will take something like Jaitley did not contest the 2019 Lok Sabha election, presumably because of his ill health, right? So now you see the translation. Uh, the same translation will not have the word to word kind of translation, right? So we will translate it how naturally the target language requires that output. So straightforward mapping from one language will to another language will not help here. So we need to make sure that the output is as fluent as normally a human being use it and understand it. So that gives us a clue that machine translation is not an easy task. It's not like a dictionary mapping kind of task. So again, let me start with one example, like the train was in the pen. Now, if I ask a translator to translate this text, the first thing what they look at it, or are these words are part of the language? If they are part of the language, okay, are these words being combined together make any sense? Of course, the sense when it comes to the part, we feel that okay, the train was in the pen looks like semantically very difficult thing to understand, because train is always bigger container, whereas pen cannot contain the container like train, right? So there is a semantic inconsistency between the train and the pen. But if I give a story, something like, okay, there was a little Tom playing with the toy train and he lost the toy train and finally he found it. The train was in the pen. So, this smaller contextual knowledge saying that the train, what we are talking here, is a toy train, but normal train. And also, the pen here, what we are talking about, is not a writing pen, but it is the pen enclosure where toys are being kept. So, the sense that we selected for the train and the pen now are totally different, because the context requires to select you the different sense. Now, this sentence looks like a very good sentence given that the context is been understood. So this is a very good example which were given by Bar Hillel in 1960, where the machine translation research was actually blooming period, I could say. And he came up with the sentences of this kind, which he calls it as a semantic barrier sentences. When these sentences cannot be understandable without having a context that are there, then translation will also be a difficult part, right? So now you could see that it is not only the knowledge of words and the combination of the words, but we also need pragmatics and world and cultural domain and whatnot, whatever knowledge that a human being possess. And in a normal setup, even the multimodal information like the image, the vision, the the all speech that is coming from the person, everything are important to interpret the meaning what the normal speaker says, and that is important even for our translation purpose. Okay, so mostly there are three steps people do it. Understand, that is the most important part. Understand the source text and convert that into target and generate the acceptable target language. In the meanwhile, we do have a lot of linguistic gaps. For example, if I ask you what would be the equivalent of the word of Chiliagan in your language, sometimes there will not be a word. There will be a word equivalent of pentagon, but even if I ask you, Chiliagan is a thousand, corner shaped pentagon type. So we might not have the equivalent in that language. And also ambiguity occurs at every level in a language. One sentence may mean multiple ways. So all these things are problematic thing. And divergences are when you take two languages into the consideration. These two languages may not be a language which derived from the same language family. They may have different kind of issues, of pattern matching the concept of one language into another language. So these kind of cross linguistic difference, we call them as divergence here. But we know that most of the time machine translations are not doing better job, especially when it comes to the Indian languages. But still people need it because of various reasons, because we want to have a rough translation at least, though we could not get, like, the high quality, adequate, and fluency wise the best model. And cross-lingual information retrieval is also becoming very very popular, because there we need to map one language to another and get the information done. And again, machines are good in terms of their speed, memory, manpower, learning, and other thing. And of course they never complain, they never get tired. So the research, like building machine translations, are always a usable task. And if any LLM, like, is able to do this kind of task, we should say it would be the better LLM, especially in the context of Indian scenario. Okay, when it comes to the machine translation, it's been done in multiple ways, starting with the rule based. As I told you, it's a little older method, and example based, statistical, neural, and now, of course, LLMs. And this timeline of this MT, you could see when it started, especially during World War II. The time, I could say, the first application of artificial intelligence is to build machine translation. Because when people started sharing the very the informations from one place to another place, very secret information, they want to encode that information in a different thing and encrypt it and decrypt it in the other side. That's where they started using computers. I think computers are also very new during that time, after or during the World War II. And they thought that why can't they use even language as a part of it, so that we can encrypt that one language A and decrypt it in the target language. So then they soon realized, as I told you, a lot of semantic barrier. They soon realized that this is not that easy to build, because language translation is not word to word mapping or even phrase to phrase mapping. It is beyond that one. So during that time, though governments, especially US, UK kind of governments, started pouring lot of money, they soon realized that building MT is not that easy. And there is a committee called ALPAC, Automatic Language Processing Advisory Committee, which gave a report saying that building and machine translation, which surpasses or works similar to human translation, is not possible even in the near future. Then suddenly, all the research that are going on in this line, especially in building the artificial intelligence thing, has stopped during 1960s kind of thing. Till that time, people have looked at the rule based approach as the best approach, and under which there are multiple things. Then only later, after late 1980s or late beginning of 1980s, people started looking at the machine translation in a different perspective. Then even today, transfer based MTs are available, are being used, especially the rule based approach. And example based MTs are being built, where you give multiple examples from the example, it's trying to create a logic, looking at the comparison and contrast across the text, and try to see how it can be mapped into the target language. Then after 1990s, statistical MT, of course, became very popular, and there they understood, okay, we need to build the data set. So the data set building are actually started, in, I could say, the late 1990s or the beginning of 2000. And again, when the internet become very popular, people started using the internet for information extraction, and started building lot of new data sets. Wikipedia become very common. So somehow the language that data becoming more prevalent everywhere. Otherwise, most of the time, the language informations are there as a published material, either newspaper or book, or something in the speech, in the broadcasting, or some other way. But when this statistical model came into the picture, they understood, okay, we need lot and lot of data to understand the language. Then at one point, of course, neural methods become very popular. from then neural methods getting very good attention. Even today most of our MT systems works in neural based encoder decoder kind of models. Okay. The same thing what I just told you are also there in the slides, so I might skip some of them now. When it comes to the rule based, of course the problem is they are less fluent, more manual effort in dictionary building went on. And again, when you want to map these two languages, the divergence that I just told you, we need to come up with too many transfer grammar rules to make sure that these languages are being kind of covered together. So all these things are cumbersome activity, as well as you might not get the better result immediately. When statistical machine translation came into picture, people started use it, learn the probabilistic from the data set. There we need a parallel corpora. Parallel corpora are kind of text where you have a source and the equivalent terms in the target language. So the same sentences are being translated, the equivalent thing, which are very fluent, acceptable, grammatically well-formed sentences in the target language. So now people understood, okay, we need a large amount of parallel data. It's not like hundreds and thousands, but we need in millions. So supposedly if we are translating from English to Hindi or Tamil, so what we need is a best target language model. That means what we need is a language model, as well as translation model. So translation model is used for understanding the fidelity, how truthful the model is to the source language, whereas language model helps us in getting the fluency, how fluent that language is in the target language. So we use argmax to build this kind of model. And the best systems are extremely complex to build, even in the statistical thing, because we need to again build separately different subcomponents, and a lot of feature engineering required, and factor based informations are required, and again lot of human effort to maintain this phrase tables, and human interventions in building this type of models are also huge. Then comes the neural machine translation. So this architecture is mostly a sequence to sequence architecture, when it compares to the classification and other thing. Here there are two RNN, recurrent neural networks, or people use transformers. Here the source language information is encoded, and here it will first initially went into the hidden state, then the target language is being decoded by, there is an encoder RNN and as well as the decoder RNN. So encoder RNN helps us in producing encoding information of the source thing, whereas decoder helps in generating the target language, right? And then the advancement with most of the NMTs, I could say, later stages, attention mechanism came into the picture, and transformers are becoming very popular. And some of the linguistic features like POS, morphological feature, parsing, that means sentence structure understanding, meaning representations, understanding, all these things can be actually people started using this information on the top of the parallel data. That means now the parallel data is enriched with some more linguistic information. This can also it's a kind of feature engineering again. In a context like where the less data available for a two language, this kind of linguistic feature always proves to work better. And subword information is another technique which has been used, because all of us know that in LLM tokenization plays a very important role, because the kind of tokenization method that we follow will help us in understanding whether the language vocabulary, out of vocabulary when it comes, whether we able to handle them through this tokenization technology, right? Similarly, the languages like Indian languages, most of our languages are word level very rich languages, I could say. That is the term agglutination, would say. Agglutination means one word having multiple information. So more of the informations are actually within the word. When more informations are in the word, how to extract them and map it into the target language is a difficult thing. So the normal tokenization will not help us in doing that one. So subword informations are being used while building this thing. And on the top of it, let's say we don't have much parallel corpora. and some kind of monolingual corpora is also being used, and to build synthetically some more like parallel data, people also we use some kind of back translation method, so that the parallel corpora that are required in building MT is much more. Okay. And there are advantages and also disadvantages when we are using neural based thing, because when we are talking about rule based method, there is a pipeline approach, I could say. It will first go for the language understanding in terms of analyze the sentences into tokens, tokens into words, words into their internal structure, and understand the relationship between words, then map it to the target language, change the sentence structure. So all these things go in a very proper pipeline. When it comes to the statistics, again, it's a less interpretable because it's based on like the presence of words, sentences that are there in the parallel corpora. It's trying to learn the probabilities out of them and try to predict the text. But when it comes to the NMT, again, it's sometimes very unpredictable why that output has been generated. But of course, when it comes to the fluency wise, the fluency is very good. Even LLM based NMTs for most of our in languages, the fluency in the terms of the naturalness that are there in the text are good. But when it comes to the adequacy, that is the meaning representation, especially how much of meaning that are there in the source, whether that meaning is being conveyed in the target. So most of the time there is a jarring in terms of adequacy in machine translation. So again, hard to debug, difficult to control, but of course, it's a single neural network which can be optimized for this kind of thing. And when it comes to the evaluation, how do we evaluate the machine translation? Normally, again, blue is a very very standard machine translation technique to evaluate. It's called bilingual evaluation under study. It's based on again ngram. So the reference text that we provide and the machine generated text that we got it from the machine translation, both are being compared for their n-gram precision. Usually it will be 1, 2, 3, or 4 grams, and plus the penalty, brevity penalty is being applied on the top of it. So it means if source and target will not have same number of tokens, and source has more and target has less, that means the translation didn't happen. It's a very crude way of looking at and the quality of the output. But after that, there are other frequencies like character frequency analysis, something called CHRF. And these days, the very common or most appreciable machine translation metric is COMET. COMET is again a model, neural model, which learned the quality assessment through human evaluation metrics. Their human get into the output and try to classify the errors into multiple types. This is called multi-dimensional quality metrics, MQM analysis. So normally human evaluates into multiple type of errors, starting with fluency, under fluency, what kind of linguistic errors in terms of there is a tense mistake, there is a plural that didn't generate well, there is an agreement in subject object that didn't come well. This is a complete linguistic understanding we try to get it. And when it comes to adequacy, how much of information is being carried out and what aspect it didn't come out. Okay, and the style of the writing, all this multidimensional quality are being captured through the human in terms of even ranking. So ranking either it let's say you give two three outputs of the same sentence and rank it. This is the best output. This is the second best output. So there are open again open assessment asking the human evaluator what happened or what is the problem, why the output is not good. So all these things are captured, and comet kind of models will understand it, learn it. So when a new text, new output is being given, it's trying to evaluate in the similar fashion. So now we are having two models. One is a machine translation model and another one is an evaluation model. Again, this evaluation model is a costlier models to build because we need to get the data done by the human. Okay, it's not that easy, and one human evaluation will not be taken into consideration. We need multiple annotators, and again this inter rater inter evaluator agreement, something called kappa score will be understood, making sure that they are going in the same line, because normally humans are the one who tend to make lot of variations in our output, because when we are happy we evaluate in a different way, when we are sad the aspects that are associated with our human cognition also affects that output quality. So to avoid all these things, the best standard method now, right now, I could say blue, people normally use it. And human evaluates on, as I told you, there are multiple ways. One is adequacy and fluency. The ranking can be given like in adequacy, there is a 1 to 5 ranking or 0 to 100 thing. So people look at the output and see whether it's going on well. Okay. With all these things now, with our knowledge on this is how machine translation works. Now, all LLMs are ready now with machine translation in Indian context. To answer this question, mostly machine translation is also done using the prompting, right? So prompting mechanism also employed for the machine translation kind of task. So what we will do is we will have a source text and we'll have a target text, and we will create a prompt generator, and it creates the prompt. This prompt translate this target language from source language, and give a text and try to call the LLM. Finally, there is a translation parser from this, whatever JSON file that we give as an input. Finally, we will get the translation. So it's a normal pipeline that normally any of our LLM application works. The similar version, machine translation also does it. And again, the tuning of prompting also shows variations in the output. So when you make an agent type of thing, saying that okay, think that you are a machine translation or you are a human translation, you translate this one into the target language. So this type of prompting technique change also changes the quality of the output. Now when it comes to the LLM based machine translation, this is our 1 year back study. So just a minute. So we have taken GPT 3.5, and also some kind of encoder decoder, the neural methods like Indic translation 2, version 2, Google Translate, and the LTRC, our own in-house machine translation tool, and Seamless M40, Llama different versions with different parameters. So yeah, as you could see, the average blue score of across all most of the Indian language, especially 22 Indian languages we have taken. So the average blue score is actually, you could see there are a lot of difference. Google Translate and also LTRC and Indic Translate, you could see the output quality is much better than any of the LLMs given here. So the reason behind again is, at least that period of time, encoder decoder method works better than only decoder method. Similarly, CHRF also has a relation between the blue scoring. So again, encoder decoder models works better than the normal thing. Now we have again taken the English to 22 Indian language translation with 5 benchmark sets, starting with benchmarks like Flores, IN22, or other benchmarks that we have selected, and we have also are trying to identify with each of the languages how the Llama models, especially the LLM models, can function to the task of machine translation. Again, you could see most of their blue scoring is not beyond 20. Okay, so when it comes to the language like Hindi, it's actually shooting up really good. But when it comes to the other languages, the quality of machine translation is actually below average. Similarly, Indian language to English also we are trying to do. It also proves that with Hindi and the other languages, like a little bit on like Nepali, Urdu, because they also have some kind of script similarity. The script similarity might have also helped them to perform better in the task. But all other languages again are in the below average. Uh, desk. Again, we also have done a small study to understand how far these languages are being supported by LLMs, because that's very important. If a language presence is there in the LLMs, of course, their ability to build machine translation is also very good. Now, the study, of course, not for Llama 3, we have actually keep doing right now, but my results are like no earlier results we are presenting here. So we have taken Bloom, Falcon, Llama, Mistral, MPT, and OPT kind of models, and also try to see whether the presence of Indian language in terms of their vocabulary in tokenization is there or not. So yes, you could see that there is a tuple, and there is a first value represents the language specific character, and the second value is how much it's been like supported by LLM. Okay, so let's say there are 96 characters which uses the Bangla script for Assamese and Bengali, out of which 48 represents the language specific character, whereas here it supports only 48. So the remaining thing is not being supported. Again, when you commit Dravidian languages, let's say Tamil, the Unicode values in language is 72, out of which actually the 46 characters are being, let's say, in the Bloom or Llama, like has a presence, but like not having a presence, but whereas 53 has a presence. So this also shows that this kind of LLMs are right now, the vocab size didn't have this Unicode value. It also means that the complete understanding of the language is not present in this type of LLMs. Okay, now of course now there are a lot of other studies that we are trying to see whether LLMs can be used as a kind of model where with the very limited resource languages, even within this 22 scheduled languages. I think I might need to go for my another slide to show how many languages are on the top of low resource, high resource, and extremely low resource kind of family. And normally in NLP paradigm, we divide the languages into 5 levels. The level 0 languages are languages where there is no presence of them in most of our internet world. So they are left behind languages. In a language, in the world, let's say we have around 7,000 languages, out of which 2,100 plus languages are left behind languages. They don't have any presence in the world. And languages which are level 1, which we call them as scraping by languages, out of which 3,500 plus languages go into that level, because their presence are there in a very low level, or they have a little bit of publication. They use that language for a particular either publishing some small information, disseminating it through some kind of thing. And there are level 2, level 3, level 4 languages, again a medium resource, I could say, are a very low to not extremely low, not even medium. So more than 500 plus or 600 plus languages will go into the picture. So the level 5 languages are actually immortal languages, especially languages like English and other 5 languages I don't want to list here now. But these languages have a very good presence in the internet. That means most of our LLMs learn these languages better than any other languages, right? So of course, now again, when it comes to the machine translation, I think I'm going to make another slide change right now. If you feel that there is a that you could like see my slide, let me just give me a thumbs up or something, because I have changed my slides into another slide now. Dr. Oswald, can you see my new slide? Okay, I'm again expecting that the slides are being transitioned properly. So now let me come to the again the multilingual part of India. So multilingualism, of course, is a very common property. We need multilingual presence in our India, and we know that out of 7,000 languages, 1,000 plus languages are spoken in India, right? There are too many languages, and we have official, scheduled, non-scheduled, dialects, varieties, whatnot, right? And India doesn't have any national language. We only have official language, English being the most common used official language, and each state has our own thing, right? And of course, when you go to any of our like common places, the multilingualism is very very common. And languages, if you look at it, the main land India, especially the northern part of India, languages like Hindi are spoken very commonly, but in the southern part we have also different varieties of Dravidian languages like Tamil, Telugu, Kannada, Malayalam kind of languages. And we do have a very good chunk of Tibeto-Burman languages which are spoken in Odia, and also Austroasiatic other Tibeto-Burman language spoken in northern eastern part of India. They are very very rich parts of India where lot of languages are spoken are being counted from here this side. And of course we do have like the apart from these four major language families like Indo-Aryan, Dravidian, Austroasiatic, Tibeto-Burman, we do have some kind of languages like we spoken in Nicobar and other islands here. And if you look at Indian language again, as I told you, the presence of their script in LLMs are not actually based on the language uh, by its nature. For example, if you take Hindi as a language, it's an umbrella term. There are multiple languages spoken under the name of Hindi. It can be Bhojpuri or Braj, Maghagi, whatever it is. All of them are being now we call it as Hindi. Similarly, if you take a language like, let's say, Tamil, Tamil also there are people writes Kodava, Irula, or Erukala, or some other languages which are spoken in different parts of Tamil Nadu in Tamil, right? So similarly, there are many languages which are being represented because they don't have a script. They use the neighboring or the most major languages that are being spoken in that area, right? So if you again look at the most diverse state in India, Nagaland has like a presence of too many languages, but their presence in LLM are not actually not very clear. Again, the least language spoken states like Kerala, again to have a presence of like let's say Telugu, Konkani, Kannada, Tulu, a kind of like Tamil kind of presence. And as I told you, Indo-Aryan has multiple languages. Tibeto-Burman is the richest language family of languages that are there in India. But their presence, I could say, is not even there in most of our LLMs. And Dravidian, again, the major languages like Telugu, Tamil, Kannada, Malayalam, you could find them. They support in the most of our LLMs, but not all languages. Again, Asiatic and the Minis languages. Okay, I'll skip some of the thing. I'll go back to machine translation in my slides here. Okay, now when it comes to the data resource, how do we call some languages are high resource languages and some languages are low resource languages? Most of the time, it's determined by the data availability for the language. Let's say this is the data, like set description from Common Crawl, which normally like has a collection of lot of language data from various like places. English is always categorized as high resource, and 45 percentage of data that are available in the internet actually goes with English. But the other low like languages like Russian, German, Chinese, Japanese again are high resource, but none of our Indian languages in the set of like high resource. When it comes to the medium resource, as you could see, only Hindi, again as I told you, Hindi that are there in the umbrella term of a Hindi is being there with the resource of let's say 0.1 percentage. And all other languages like Bengali, Tamil, Urdu, Malayalam, Marathi, Telugu, most of our Indian languages are still called as low resource, and we also have extremely low resource languages too, right? So now the features that are there in Indian languages, very very rich features linguistically, none of these languages can be mapped towards it. So then LLMs are being built with the majorly high resource languages, and with the presence or with the small presence of our Indian language scenario. As you could see that the activities like machine translation are still incomparable with the traditional methods like sequence to sequence kind of task. That's because of, again, data presence, again, I could say. Again, languages are, like, as I told you, agglutinating. That means one word having multiple meaning, and, like, informations are very common. For example, in Tamil, udai theriya சொல்லிவிட்டு சென்றான். So you have multiple informations that are there within the word, right? And similarly, nouns can also have multiple information. So rich vocabulary, richness in every aspects of life, culture, art, science are there, but still we are in the hands of low resourceness. Okay. And and our languages also do show linguistically different type of thing, the politeness and the linguistic features of one language cannot be mapped exactly as it is in another language, right? So all these informations are there in our language data. When the presence of these informations are not there in another, but definitely it might not work better. And of course, I'm not going more into the technical side, I will skip some of them. So, for example, one of the example I would like to show here. This is one word in a language like Telugu. Okay, only one word which is an equivalent of multiple classes, not even phrases, multiple classes. So, for example, పగలగొట్టించి పెట్టమని నివ్వదలుచుకోలేకపోతున్నాను. It's a one word which means I could not think to permit someone to tell for my sake to break something, right? So now you see the tokens that are there in English and the tokens that is expressed in Telugu, and in incomparable, right? So when we ask these LMs, which has the presence of 45 percentage of data from languages of high resource, 45 to 50, and the other language presence are very less. Of course, when you see the generation of our languages, the quality, we cannot express. So the hallucination and the wrong generation, linguistically bad outputs are very common. That kind of error identifications are a very common process. Normally people keep doing on it. Okay. And what will we do when we are living in a low resource context with a high rich information on words? All right. So all these two things are very important thing, because let's say ours is a low resource, but our language, Indian language behaves similar to English. That's totally different. So you can just create some synthetically build some data, but it is low resource. At the same time, there are different richness are there. Okay. So similarly, the data has to be make sure that the richness is being captured as it is, and uh, this has to be processed further. So we need different methods to do that one, starting from tokenization, as I told you, this byte pair encoding or sentence piece type of tokenization. For English or Hindi or other Indo-Aryan type of languages, it might work better. But when it comes to the Dravidian and Tibeto-Burman, where a lot of informations are within the word, and splitting them, here and there without having a meaningful element associated it, most of the time, resulted in bad generation in our output. If you have used any time Indian language in the LLMs, you just go and ask, okay, can you tell me a story in Tamil? It generates the story, but there will not be, the words that are generated might not look like a Tamil word, or there will not be kind of coherence between one sentence to another sentence. This all because of the tokenization technique that are being used for this highly resourced languages need to be looked at it in a more careful way, because it should reflect that language as it has. Similarly, segmentation, analysis, especially morphological analysis, part of speech, chunking, all these things are very important as a pre-processing when we are working in a low resource context for the languages. Again, normalization can come in multiple ways. It can be a Unicode. For example, if some of you know Tamil here, the word cow over here looks like there are two Unicodes, like something like K and La, or it also can have its own Unicode like cow, right? So in a text, when you have the rendering looks like the same, let's say whether it is value of ka with the vowel O, or it can be a ka with the vowel A with La. Okay, so there is a three Unicode points here, but there are only two Unicode points here. So this rendering also need to be normalized. The languages, when you take the data from any open source places, even starting from Wikipedia, the rendering looks like a good, but when you look at the Unicode values, they are different. So, right, so this Unicode normalization, the pre-processing step before getting into LLM are very important. And also, multi-token words are very common, especially in Indian language context. We tend to write multiple words together. Okay, they are two separate words, two separate part of speech thing. For example, idam agum. Idam is a noun, agum is a verb, but noun and verb are being clubbed together to generate as one word, right? So these multi-token words, when they, let's say we are splitting in a tokenization using like some kind of white pair kind of thing, it should not separate it wherever it required, but it should separate in a different place, like in a proper place. Similarly, morphological analysis is important because when a word is of bigger length, splitting them in a proper point and trying to understand the internal structure, so that before getting into the actual tokenization, we are making sure that there is a meaningful element in the breakage. So that kind of pre-processing also helping us. That is what we are working on a paper where we are trying to prove that the understanding of word structure is very important, than just going crudely into splitting them into multiple pieces. Of course, POS tagging is another thing which are being used very is one of the NLP tool. Normally we use it for any kind of pre-processing. Again, in a low resource setup, when we have a very less data, having POS tagging and chunking. Chunking is group them into phrases and build the data. Uh, and I'll not go into the steps and other thing, where you try to identify the structure of the sentence. For example, நான் அந்த பெண்ணை குதிரையுடன் பார்த்தேன். Now, with the horse, who has that horse? That I or a girl is a very challenging thing unless we have again a better context, right? So வயதான ஆண்களும் பெண்களும் வந்தார்கள், old men and women. Who is old? Either it's both men and old or only men, right? So this kind of structural differences, the interpretability is also very difficult in a language unless we do have a context. So what parsing normally does is it's trying to parse the sentence. See, for example, here Kumar idli sapitan, you could see the pronouns. It's been identified as a proper noun verb. This is the task of POS tagging, and it is been identified as the root. Root is Kumar. It has a masculine singular third person information. Sapitan, sapidu is the root. It has a verb, masculine singular third person, past tense. Okay, and polarity is a very positive thing. So all this internal information of a word is being captured through the morphological analysis, and on the top of it, we also try to see what is the role of each of the word in the sentence, whether this particular word function like a subject, it is an object. This is the, again, this is a dependency tree. I'm not going more deeper into that one. So trying to understand what role each of the word are playing and how they are dependent to each other. Okay, so finding out this kind of internal as well as internal intra and inter word informations are very much helpful when we are working with low resource setup. Okay, so for building such kind of information requires a lot of linguistic inquiry, because anybody cannot do it. We need at least some kind of language understanding, trying to see how the language is being functioning in a particular context. Building such kind of data sets are very much important even today for most of our Indian languages. And again, when it comes to the multilingual NLP, let's say LLMs, of course, they have the capability to have a understanding of doing multitasking, but can they do multilingual? Because the LLM has that capability, but normal encoder decoder kind of models still not that very clearly do multilingual part, though we can train the complete multilingual parallel data and tag it as okay, translate from Tamil to Kannada. It might do it, but the quality and the efficiency of the encoder decoder model is not that again difficult, but whereas LLMs are very much capable of doing that one. Okay, this is again extremely important for a low resource setup. Again, we use different kind of technique to build this one. So one of the technique I'll tell here is LASER. It's a language agnostic sentence representation where you try to get the source language documents in different languages, and it will go to a classifier which is called LASER classifier, and it predicts the label in the target language. And on the top of it, the target language documents can also be fine tuned, and so using some kind of zero shot classifier. Then, of course, the pre-training of the Wikipedia coming from the pre-trained LLM, then fine-tuning all of them together and use the classifier to build the thing. So it's a method to, to make sure that it's generating the multilingual data coming from different kind of places. Of course, again, this multilingual LLMs, similar to LLMs, there is something like MLMs. Most of LLMs are MLMs these days because Llama 3.2 now proved to be supporting multiple languages, including again the let's say I could not say more than 10 Indian languages. It works better when you have thousands of again languages. It works for some languages. Again, the tokenizer plays again important role, as I told you, and transformation architecture, and the training data set, and the fine tuning method, especially tailoring to the requirement of our task, either it is a translation, sentiment analysis, or text generation kind of thing. And when it comes to the encoder based multilingual pre-trained data with Indian language support, that's something like MBERT, Mural, IndicBERT, XLM Robota have the support, which again not all the languages. When decoder kind of model, MGPT, again useful, but encoder decoder, of course, based language models, not a large language model. Again, this MT5, MBOT, IndicBot are all already available, especially for which has a support of some of our Indian languages. Again, uh, uh, the Indian languages, what I told you here, are only Assamese, Bengali, English, Gujarati, Hindi, Kannada, Kashmiri, Malayalam, Marathi, Nepali, Odia, Punjabi, Sanskrit, Sindhi, Tamil, Telugu, and Urdu. So then, what will happen to all other languages that we are talking here? That support is not yet ready. Most of the LLMs, forget about LLMs also we don't have. Okay, so this I will leave it. And the challenge here is, of course, creating high accurate data, because when you don't have quantity, what we need is a, like, let's say, quality, right? Normally when you have a low quality high quantity data, also LLM works better. Similarly, when you have high quality and low quantity, also it work. So at least one of them should be high, either quality or quantity. When you don't have a high quantity data in our languages, what we need is a high quality data. So high quality data requires to make sure that it is curated by human, and it is enriched with a lot of linguistic information like part speech, morphological analysis, parsing, and make sure that it with a less quantity. uh, we make sure that, the model effectively learns the data in comparison to the high quantity. Again, biases and other things are also embedded in all our models, as you see, and machine translation is no way exception. It also, inherits the bias that is there in the source into the target, because let's say some languages do not have gender, specific words. Let's say there is no specific words to say he she it, like in Hindi, wo is a pronoun which is used for he she it, but in a context we will know. But when it comes to the Tamil, it needs an like pronoun like aval, avan, adu, like totally separately. Similarly, the agreement should be properly done. So whatever there in the source language, when we are working in a multilingual context, one language has high resource data and some languages have low resource data, the bias normally crypted into the low resource languages. So the mitigation of those bias is also another challenging aspect. People are keep working on it. There is a lot of road towards doing research on that aspect again. And of course, the resource intensiveness is too much. Again, it's not only in the data, even the hardware thing. And multilingual language models or large language models are, of course, very resource intensive, can and they can struggle with languages when they are dissimilar, because as you know, in Indian languages itself, not all languages are same, right? Each language has its own thing. So what we need is a seamless language agnostic approaches here. So that is the one which we need to achieve if we want to build a good machine translation language. And in summary, I could say that we have LLM's approach is, it should be like, though we are looking for language agnostic, but the technique that we need to follow, either in terms of data architecture, make sure that the language specific features should not be forgotten. It should be captured through that one, so that the output looks like a very like fluent output for the readers. Okay, so by this I'll stop here, but meanwhile, if you have any questions or anything to be asked, you can do so. Dr.
Participants,
Aswal, is time fine, or
yeah, we are on time.
or
It's perfect.
okay.
Yeah.
Yes.
So participants, you can share your questions, please. Ma'am will moderate it.
I really don't understand the participants because, okay, there are how many of them are here?
Around 316 as of now. So we
Okay.
have PG scholars, PhD students, and faculty from across the nation. So we have all language speakers almost.
Oh, that would be good to know. Okay.
Yeah, so we
So,
had around 400 in the weekdays. Today, maybe because of Saturday, yeah,
okay.
little bit the count is down.
Yeah.
So mostly we have
Yeah.
50, more than 50% are faculty members.
Wow, very interesting. Okay. So
Yeah,
yes, I'm doing research in language, Venkataramana Bhatla. Very nice, sir. I think keep doing it. Yes, we do lot of work on Telugu at Triple IT Hyderabad. Please do visit whenever you want. Yes, you are always welcome. Okay, you are
so
working on offensive language.
so I have look, so somebody's asking, does Laser support Telugu language? Ma'am?
Yes, it does have the support of Telugu, but we having gone through that laser kind of task, multilingual thing using LLM these days. That laser is a most of like encoder decoder. But if you want to go for decoder, I don't know it even go for laser. The normal fine tuning method will work better these days. Okay,
So
for machine translation task, to choose between model size and efficiency in LLM. Yeah, I think most of the time our models are like six. I think what is the parameter size we use? I think 16. I think my research scholars do know it better, but we don't need a bigger model size over there. The lower model size also works better.
thank you, ma'am. Definitely. So, um, so is there any research scope for sign language
Yes,
translation across Indian languages?
going on. I think the lot of people working on in Punjabi University, there is a professor who is working on, and from Triple IT Hyderabad also there's a professor called Jawahar who is working on. And as I know, there are a lot of people working on sign language translation. Again, this is a difficult field again, because in sign languages also we have different dialects. All sign languages are not the same. So, but sign language data sets are not that very commonly seen. But there are some works you can search it online. But if you want, you can write it to me also. I can give you. Okay, my contact, my email ID is what I'm going to give. Just to give a second. Okay, so can we utilize quantum computing support for NLP? I think yes, possible, but I'm not right now expert. But I think definitely it's possible, because, but do we really need hammer a hammer for like putting a small pin in the notice board? or only your hand is enough? That you have to see most of the time LLM looks like I have to use LLM, but some tasks you don't need LLM. You can even still use the, like, non LLM based thing. Similarly, NLP, I would not say that there is an LLM available, so we have to use LLM, or there is a quantum computing available, we have to use quantum computing. Of course, there are unsolved issues still, may require high computing, high architectural thing. So maybe we can explore such type of technology there. How to get data set for multilingual? Yes, of course. Now the Indian government initiative that is called Bhashini. This is a national language translation mission. They are, actually, we are all part of that one. We are putting most of our data sets free over there. You can get them similarly in Hugging Face, Kaggle. Also, you can get them. AI for Bharat is a, I think, wonderful thing that they are doing. Their task also, data sets are available. Opus data sets are available. Wikipedia dumps are available in multiple languages. So data set, you can easily get it from anywhere, but not for all languages. Again, as I told you, only few language. Any language closer to Telugu, of course, sir. All Dravidian languages are more or less the same. All Dravidian languages, I could say, more closer. And but though it is closer to Telugu, see, for example, the language called Chenchu, which is spoken in Nallamala forest of Andhra Pradesh, more or like looks like Telugu, but they have a very specific words, terms that are associated with their lifestyle. So languages may look like a closer, but each language is different. But the closeness is is beyond expressive, because let's say all languages are coming from a same language. Let's say Dravidian, there is a Proto-Dravidian from this Telugu, Tamil, Kannada, Malayalam. Slowly they have been separated to each other. Some kind of divergence, like some kind of convergence, similarity across languages you could see. Similarly, some lot of, like, divergences are also possible. Okay, can we use ML or DL for doing this research? So it's depending on, again, the data set availability, computing availability. If you have a smaller data set, go for language model based research. If you have more data set, go for LLM based research. It's depending on the data set. Data plays a very important role. That's what we should understand. And our architectures are like keep evolving, but the data is the one which we need to make sure it's quality. So it's depending on the data availability. You can go with whatever model that are required. But for a machine translation, even today, sequence to sequence modeling for Indian languages works better than LLM based approach. Okay, how does transfer learning or multilingual pre-training improve performance in machine translation for related language? Yes, sir, that is also there, because similar languages have a similar, like, embeddings. That kind of research is also going on across, like, various institutes. So like, when you have a multilingual pre-training for a one language, let's say Tamil, the Kerala, like let's say Malayalam, the presence is not there, but more or like they are same vocabularies. Like in terms of scripts, they are different, but when it comes to the vocabulary, they have a shared properties. So one language helping another language is also be a part of our transfer learning approach. And synthetically building more and more data. Let's say Tamil data, transliterate it into Malayalam script, make it a Malayalam data. So all this synthetically building data also, that is how we can build a large corpus. We cannot build a corpus like normally human written corpus for all languages. So yes, that's also important. And also, actually, they one of our thing that we are doing now, they also shown that pivoting one language through which, like, translate other language. Let's say you have a Tamil, and but we don't have a Malayalam to like English. You have a Tamil to English. So pivot that language into, let's say, like convert that Malayalam using some kind of rule based approach into Tamil, then translate it to English, and pivot that one into Tamil and translate it into English. The pivoting is also helping in some ways. What about primary data set is suitable, viable? I don't understand what do you mean by primary data. If you say the primary data is for testing the model, or then of course that's a very important data set that we have to keep in memory, because testing any model with a very authentic data, gold data, is very important. How agglutination is handled by current LLMs. So as I told you, current LLMs uses again tokenization method. That is how it's been handled, but there is no other exceptional way language model uses. It is similar to how English is been handled. Similarly, it's been handled. But that was also one of the reason most of our agglutinating languages not working better. So we might need to tweak that, tokenization little bit differently. That actually, whether it solves our problem, or we, because these days, truly speaking, transformers are doing wonders because it's trying to learn the whole context, right? So agglutination is always a problem when it comes to the generation part, though the tokenization is being properly, let's say they are doing the tokenization, but when it comes to the generation, combining them together is still a problem. That's why hallucination happens in most of our LLMs.
Participants, are there any more questions? There is one more question.
Okay, should we create data set from newspapers? So it's not about that. If you are working with a domain specific thing, let's say you want to translate legal documents, you need lot of presence of legal documents into the thing. Domain requires a domain specific. General data can be taken generally, but we need all type of data. There is nothing difficult in that one. We need all type of data. Even these days we are working on spoken data, because spoken data are totally different from the written. It has its own issues like disfluencies, and ellipses, or other features. So we also need all kind of data from all kind of age group, literate, illiterate, or male, female, or children. We need all type of data from all kind of sectors as well as in all domain, if you are building a machine translation. Okay. Yeah, the questions are all more like attendance and exam, I think. Yeah.
Yeah, they're worried about the exam and test now.
Don't worry, you will do better. And Dr. as well, you have to pass all of them. Yeah.
Yeah.
They are diligently attending all the sessions, I hope. Yeah.
Yeah, definitely is. They're giving a wonderful cooperation to us for the past 6 days.
I know. Being a teacher is different, and being a classroom student after being a teacher is very difficult.
True,
So,
exactly. Makes sense.
Okay, ma'am, thank you. Thank you very much for that detailed discussion. We have learned a lot about machine translation. And this is the last session of our FPP, but yours is only the second talk, more specifically about Indian languages. So we are very thankful to you for
okay.
that. On behalf of all the participants and the Department of CSA and NIT Tiruchirappalli, thank you very much, ma'am.
So
Yeah,
from
thank
my
you so much.
side, so your talk was like a cherry on the cake, though it was the last session. It was like a cherry on the cake, I would say, because you addressed very elegantly about how Gen AI could address the complexities of the Indian language translation technology. It was both inspiring and relevant in today's India's rich, diverse, linguistic landscape. That's what I would say. And we really humbly appreciate your efforts, Dr. Parameshwari, in delivering such an interesting talk amongst a busy schedule. But I was happy that we were able to have you with us today. We have around 33, 50 participants in the session right now. So we give you a virtual round of applause for your great time and the work that you have done. We'll be happy to see you in our campus sometime in the foreseeable future. And deliver the talk. Thank you so much for joining us today, and we'll keep in touch with you. And some of the students were asking for internships in IIIT Hyderabad in your team. Any would like to give? Any clarity on that?
Yeah, Yeah, we do get interns mostly. Please, you can go to my page. If you search online, you can get my page where I have an internship form. You can fill that internship form. Maybe I can give you right away the internship form link. Just give me a second. And you will be given the task and interviewed, and we will be taking, because we cannot of course accommodate most of them, but yeah, the people who are really interested, want to do something, please contact us. That will also be
If,
helpful.
even I want to come as an
You can,
intern.
sir,
Yeah,
please. No, no, no.
yeah, because we had a very good experience when we were at the campus. Yeah.
And we do have this year a summer school. Last year, I think Dr. Aswald was also here. This year also, we do have summer school on multimodal NLP, where we are trying to see speech plus text interface in NLP and how they are going to work. So you can apply, but there are limited seats because of the hostel and the institution's requirements. So we might not take more than 40 to 50, but based on your work experience and the background, we will be selecting for them. So how to apply for the summer school? Of course, we will be advertising it. You can follow us in LinkedIn and other thing.
If you
ILTR
could
seat
have some
criteria.
brochure or something, if you could send it to me, ma'am, I can send to all the participants.
Yes, thank you. Yeah, I will be sending that details to all of you. But yeah, don't worry if you don't get a seat, because again, a limited seat and a limited thing. But yeah, the other information you can find it from our website for more. Okay.
Excellent. Thank you so much again, Dr. Parameshwari. It's a pleasure we had you today.
Thank
Yeah, we'll keep in touch with you. Thanks again.
Yes. Yeah. Thank you. Thank you once again. Thank you.
Thank you, ma'am.
Yeah, so ma'am, I request Dr. S. Usha Kritika, ma'am, to take over the session.
Okay, I request all of you to kindly log into your Atal portal, and on the left menu there is a option called assessment. Please, please open that, and once you click on the test link, it should open for you. The attendance has already been updated.
Participants, we request you to log into your portal and look at your link for the test.
Those who have the link for the test could please update in the chat, please. If there is anyone who's attending the test, please update in the chat.
See, you don't have to worry about the attendance. You will get the link for the exam. So just you have to go to the link and take the exam. So some of you have already started to take the test. Please look at your test link. It would have started from 6:30. As we've already mentioned, it's for 1 hour test with 50 questions. Each carries 2 marks. So the test would have started. You can take till 7:30. And after the test is over, you can go to the feedback link in your Atal portal, and you have to take the feedback. So both exam and feedback has to be taken for getting your certificate. So no need to worry about the attendance. It has been already updated. So just see the test link and take the test. Take the test.
Participant, please go to your portal, and on the left hand side you will have general details, profile, FDP, applied FDP, attendance and assessment. You can click on the assessment and get the test link.
No. Okay, participants, so listen here. So nothing to worry. If you're not able to take the exam, nothing to worry. See, we have already updated the attendance in the AICTE portal today. And many are able to see that. And many are able to see the link also, and they are taking the exam right now. So if you're not able to take, nothing to worry, don't worry. Okay, so maybe it's a glitch in the AICTE website because they're updating the website from for the coordinator and the co-coordinator credentials multiple times. Okay, because it's going across the whole nation, and many FTPs are going across, right? So because it's a glitch in the AICTE portal, that is the reason you are not able to see. But we have already updated the attendance. Okay, and test link is also enabled, and many are taking the test. Okay, if you are not able to take the test, nothing to worry. We will be enabling the link very soon in a day or two for all of you. People who are not able to take, we need to find out because there's a large audience of around 700 people. So we will check the portal, and people who have not, people who are not able to take the test, we will again enable the link for all of you in a day or two. And you will be given a chance to take the exam if you have the attendance cutoff. Okay, for all those things, you will be getting a link to take the exam. Okay, and your certificate will not be affected, provided if you clear the test, definitely you'll be getting the certificate, nothing to worry about. Did you get the point? So people who have not got the link or not able to see the link, okay, nothing to worry. It is there is a glitch in the AICTE website. Okay, that is what we could understand because people are taking the exam. So we will again enable the link for all those people and all those eligible people, and definitely you will be able to attend the test. And if you're clearing that, you'll be getting the certificate for sure. So people who have attended all the days, if people who have attended, the FTP, genuinely, you will definitely get the link. Nothing to worry about. You will not be missed. You will not be affected at any cost. Okay, don't worry. So we'll be sending the link to all of you. People who have taken the exam already will not be able to take. People who have not taken will be able to take for sure. So we will send you the email because we have the email for all of you. We'll be communicating the email. So as we have already communicated, we will be communicating in the email. So please give us some time because this is a glitch from the AICTE portal because it's getting updated frequently. We'll communicate everything in the email. You need not have to worry about. Definitely, you'll be able to take the test if at all you're not taken. And in case you're clearing it, you're getting the cutoff, you'll be definitely getting a certificate for sure. Okay. So we are sorry for what has happened to the AICTE website because of this glitch. We are extremely sorry because from our end everything is clear. We'll check with the AICTE and we'll get back to you very soon. What has happened? I mean, are you able to take the test? Many are able to take the test, right?
You replied that.
I have spoken now.
Most of them.
No, now we cannot do anything, yeah. We should not get panicked first of all. We cannot do anything now, right? Now we have to understand what has happened, and then we have to give the link to all of them again to take the test. People who have not taken already will not be able to take, but people who have not able to, people who have not taken now will be able to take further. So we have told. Yeah, are you able to?
I can.
Yes. Yes.
I just hit the start button. Then proceed to
That's what we get. You are able to see as per se.
the